Hello, everyone. So in this lecture video, we'll talk a little bit about compound interest when we're dealing with annual compounding. I want to look at the comparison of compound interest situation and uh, compounding and a simple interest situation. So let's say I'm going to do two different situations. So we have um, an example here, and this example will be a person, say a student, invests or puts $10,000 in the bank and wants, and the bank has an annual interest rate, as an annual percentage rate, APR, remember that's annual percentage rate, of 5%. Okay, okay, so we'll do two different questions. So what is student's balance? This is dollars. Student's balance after 5 years if uh, if A, simple interest is used, or B, compound interest is used. And we'll say annual compounding interest is used. All right. So we're going to discover what annual compounding is as we answer this question. So here's our answer. For A, it's a bit of review. Recall for A, what's going on here. We need to calculate all of our variables here. Our P is the principal, and the principal is $10,000, the initial amount. And you can think of the bank as being the lender if you want. Or sorry, the student as being the lender and the bank being the the annual rate is, remember, we need to do a percentage here. We need to do a percentage here for, or sorry, a decimal version for the percentage here. So this is going to be 0.05 because this is the decimal version of the percentage. And then the term is equal to 5 years. So I have 5. And we can use, and what we're trying to calculate here is the student's balance after 5 years, which is the future value. So here we're calculating the future value. And if you'll recall, there's a formula for that. It's P times 1 plus RT. And that's equal to $10,000 times 1 plus 0.05 times 5. Okay, which is 10,000 times 1.025, and that is equal to 1,000 or $10,250. So the student over a period of 5 years gets oops, I made a mistake. Pardon me. It's not 0.25, 1.25. Excuse me on that. So this is 1,250 or 12,500. There we go. That's more like it. It looked a little bit low. All right. With that correction, the students made $2,500 over those 5 years in interest. So that's their current balance. But actually, this is really not. So it would be very hard to find a bank that did use simple interest. It's very uncommon. And instead, compound interest is used most commonly, and not always annual compounding, but certainly some kind of compound interest. So let's see what's going on with compound interest. So we still have these quantities. They're all still the same. Nothing has changed. But now we're going to kind of think through what happens over time. So in compound interest, we think of what the student has in their bank account. So year 0, so end of year one, what happens? Well, the student has not touched their bank account. They've just put $10,000 in, but now they also have a year's worth of interest. So this is the first compounding of the interest, is that they have the $10,000 times the rate of one, and that's 1.05. So they're, oops, pardon me, 0.05. So this is at the end of year one. That's what they have. So this is equal to, if you want, $10,000 times 1.05. So that's 10,500. Now, what about the end of year two? At the end of year two, what happens? Well, the bank doesn't say, well, I'm going to pay interest on your initial 10,000. The bank says, okay, well, you had 10,500 at the beginning of the year. So you're going to have that much in the bank, and they're going to pay you the interest on your total balance at the end of year one. So that's 10,500 times 0.05, or 10,500 times 1.05. Now, here's where we're going to make an observation. This number here, 10,500, was calculated up here as this. So I'm going to go ahead and use that and realize that that's 10,000 times 1.05. And that is, this amount is equal to that. So I'm just putting that in here. But then times, again, another 1.05, or 10,000 times 1.05 squared. Let me move all of this over so that we're not staring at the bottom right-hand side of our screen. Oops. Let's do one more. If we look at end of year 3, what are we going to do? The end of the year 3, what do we have? Well, here we have the total from the end of year 2, which now I will write just as the end of year 2 is 10,000 times 1.05 squared. That's the balance at the end of year 2, plus the balance of the end of year 2, which is again 10,000 times the rate, times the interest rate of 0.05. So this is the additional interest from year 2 that's landed. But again, we can take this quantity here and here, and we can pull it out. So we get that this is 10,000 times 1.05 squared times 1 plus 0.05, or 10,000 times 1.05 squared times 1.05, or one more time, 10,000 times 1.05 cubed. Now let's see if we can see a pattern. I'm going to go up here. Let's do some circling here. Okay, so these are the first 3 years, and I'm gonna do this. I did this thing here, right? I took a number, and instead of just writing that number, I raise it to the first power. You can always do that. And now I'll use my rare highlighter. Let's do it in green. Let's look at that exponent. We can see that that exponent is the same as the year. And that might lead us correctly, I'll say, to assume what we would get at the end of year 5 or the end of year 10 if we had to. So the end of year 10 of 5, skipping 4, year 5, we'll have 10,000 times 1.05 to the 5th, which, if we want to calculate it, it's definitely handy to bring in a calculator. I think a scientific one might be better. So let me clear this. And I will take the power first. That's always, for me, a little helpful, 1.05. And now I'm going to take this x to the y is what I'm going to use. And I'll put in the power 5 here. And then I will multiply. Well, I can evaluate that, or I can multiply by 10,000. And I will get the answer $12,762, and for good measure, 82 cents, rounding up. And here is my answer for part B. Okay, so let's compare now the two answers. So in the simple interest case, we had 12,500. It was easy to compute, but it didn't favor the person putting the money in the bank, because in the compound interest case, this is the compound interest case, we pulled in an extra $262.82. And that is because the interest is not only counting towards the principal, it's not only being um, applied to the principal, it's being also applied to the interest as it builds. And so we're getting more money from that compounding interest. Okay, great. So from this, we can write down the general formula, and that's what I want to do next, is write down the general formula for compound interest for annual compounding. So an investment, so here's a formula, an investment, or if you think of it as, well, let's just say an investment of principal P rate R and term T compounded annually . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . has future value f equal to p. And in the case of simple interest, it would be 1 plus RT. In the case of compound interest, it's actually something very different looking. It's 1 plus R to the tth power, an exponent of t. And that's what we see here, is here we have our principal. The 1.05 is the 1 plus 0.05, and the 5 up here is the term t. So this is a good formula to put into some notes that you might use on an exam. But please do, if you do this, please make sure that you have two things clear, one of which are two words clear. And I guess I should probably say compounded annually. Those words are important, not only that it's compounded, but that the period of compounding is every year. So we will see in the next lecture what to do if we compound every month or every quarter. We'll see how to handle that